Hello, everyone, and thank you for joining today's Oracle Management Cloud webinar. I'd like to introduce you to our presenter, Eric Benner. Eric is an Oracle ACE Director, and he is the VP of Enterprise Transformation here at Mythix. A couple of quick notes. We have the phone lines muted, so please type your questions into the text box. All right, we're going to get started. I'd like to pass it over to Eric now.
Thank you, Jason, for the introduction. We'd like to thank everyone for their time today to learn a little bit about Management Cloud and how machine learning can help their enterprise operations and make their end users a little bit happier on a day-to-day basis. A little bit about myself. Everyone's always asked why am I the one presenting. I'm VP of Enterprise Transformation at Mythix. I'm also an Oracle ACE Director, which is Oracle's basically top tier of technologists, technology evangelists. There's about 100 of us globally, give or take, at any one point. ACE program itself has 600-700 people in it. So we're kind of the top people in that program. And to get in that program, you basically not only have to have a deep understanding of the technology, but you also have to be able to talk about it, communicate it. Pretty involved with a lot of these technologies we're going to talk about today. I've been working on Linux since the early 90s. I've been working with Oracle since version 7 back in 94 from a database aspect. Worked with Solaris for a long time as well, and worked with a lot of different technologies. Gives a little bit insight, especially in a technology like Management Cloud that covers the whole gambit of different technology stacks out there. Done a couple books in technology space as well, which just shows some of the capabilities not only that I have, but Mythix has in implementing these technologies for clients. Fairly active on social media, both on the Mythix blog and my personal blog, as well as on Twitter. And I do promise on the Twitter feed, it's technology news. In that space, it is not pictures of cats. So if you're expecting that, wrong place to go look. Very involved with the different user groups as well, both IUG and OAUG. IOUG is a great place for core technology, database, WebLogic, cloud infrastructure. OAUG is a user group more around applications, ERP systems, EPM systems, supply chain, things of that nature. A little bit about Mythix, if you're not familiar with us. We're one of Oracle's largest partners in North America. We're unique in that we focus in the Oracle technology space, and that gives us a depth of experience. We often see what clients' challenges are multiple times a year with our consultants. So they have a lot of expertise and experience with dealing with the complexities that your business and your agency will experience. We offer a full range of services for clients. I call it cradle to grave. We can help architect a solution. We can help you through the procurement process with Oracle on the solution, and we can implement it for you and then handle through our managed services team the day-to-day operations of your environment. And the beauty is we don't care if it's a cloud environment or an on-premise environment or some sort of hybrid environment of mixing cloud and your on-prem environment. We can handle that regardless of the situation. And it puts us really unique in this space of being able to help clients. Here we're going to talk a little bit about the role of the DBA. And you're asking, well, why am I talking about the role of the DBA? Well, this is really morphed. It's not just the database admin that's changed, especially with this transformation we're seeing the industry moving to cloud. And don't limit the conversation just the DBA. It's really the admin in general and how that's changed and the responsibilities and what's expected out of your admins, whether they're a database admin or application admin. The roles have really changed there. It used to be admins would focus on like the database and the things around the database. You'd be focusing on a lot of the technologies, whether it was storage or it was the network or the application server. And that's really changed where admins used to be able to specialize on it. And now in this cloud world, we're seeing where applications are expected to branch out a little bit. And the DBAs are being asked to learn more about how the servers operate. And that's becoming more and more common in the environment. But it's not just that. They're looking at the storage and how that works. And then the people that used to run the operating systems, the server admins, are also picking up the network and having to understand how the network relates and how do you move data between the different components. But what's important to really focus on is that all these roles of the admins, regardless of the type of admin you are, it's really about supporting the applications. Because without the applications, there really isn't a need for these systems that we're building and designing and monitoring for our customers, which are eventually the end users. Top concerns, talking with people about what are your concerns as an admin? Well, the first thing everyone looks at is how do you monitor? Is your database, is your system up and running? Is it performing? And it's not just the database, it's the app servers, the switches, the storage, even the cloud itself. But it's not just about monitoring. That's one piece of it. It's also how do you troubleshoot? How do you isolate and fix problems? What's causing the problem in the environment? Often I've seen clients that have rolled out technology, an open source technology that will tell them something's broken, but it doesn't really tell them what's broken, and it gives no insight on helping them fix the problem, helping them isolate and understand what's causing the problem. And the last piece that people really miss out a lot is how to analyze and plan. How do you avoid the issue in the future? And that's something that a lot of people kind of miss on in this industry right now, is everyone focuses on monitoring. You have some people that are looking at isolating and fixing, but having the foresight to think about how to future-proof it, how to plan to avoid outages is something that's really starting to come to light with these technologies here. And that's kind of what this management cloud does, is all this and a little bit more. But you have to change a little bit how you think. You just can't think of what is your data, how do you manage the database? How is that being monitored? And that's usually how we think about it. When you look at a technology that's going to be monitoring and managing and securing your environment, think outside the database. You have to think about the entire system as a whole, not just the database, but all the systems, all the components that make up your application. And I use systems with the uppercase S because it's not the operating system, it's not the database system, it's not the application system. It's everything that makes up that environment that keeps the application up and running, that keeps the users being able to do their role with the application, to consume the application, to work with it. What's common there is people have used older threshold monitoring systems to monitor their systems. And the problem with threshold monitoring is when you set a metric, either high or low, it doesn't really always point to a problem. An example is if your CPU is at 80%, set an alert. But just because your CPU is at 80%, that could be perfectly normal on a Monday morning when everyone's coming in. So these legacy systems tend to generate too many false alarms. And if anyone out there that's technical knows this and experiences this, we all have filters in our email that says if an email comes from the alarm system, go stick it in its own folder, because 99% of the time the alerts coming out of the system are white noise and they really don't help us as a rule to troubleshoot and to work with the problems. That being said, threshold monitoring is still useful. I find it very useful when I'm looking at things like storage capacity and planning on things like array capacity, where if you know the array is at a certain percentage of utilization, you do want to go ahead and start the procurement process. But outside of some niche cases, really start rethinking how you monitor, how you work with the systems. And instead of getting alerts on a threshold, did I artificially exceed a number? What if the alerts change where they're really giving you an alert on a problem? What if they're telling you that, hey, my CPU is abnormal, my database transactions are abnormal? Or better yet, it's abnormal for a user to take this long for this component. When a user clicks on this button in the application, it's taking abnormally long for that user to get a response. And that's really what this management cloud technology is about. It's about moving from a model of thresholds that have been artificially set to really identifying problems and what's abnormal, what's different in the environment. For that, machine learning is a key technology, and this is something that Management Cloud has built into it. And it's built into it in a way that the user, the administrator of the system, doesn't have to become an expert in machine learning technologies. You don't have to learn technologies like Python. You don't have to learn technologies like R. You don't have to learn concepts like clustering, like neural networking, because Management Cloud takes all those type of technologies and presents it in a way that's already built for an IT and IT operations role. And it does this because it starts off where it starts learning normal patterns in the environment. And it's pre-built to understand this is a switch, this is a database, this is an app server, this is a cloud environment, this is a hypervisor, and it has normal models of what those things could kind of look like or metrics around it, and then it starts learning around that type of device, that type of entity, what's normal or not. It then starts, once it learns what's normal, it's able to start giving you an alert of when there's an outlier, when there's something abnormal. And that's really critical because instead of showing that you've artificially hit a limit, it learns what's normal. It learns what's normal for a Monday morning. It learns what's normal for the third weekend of the month. And then it's able to tell you what's abnormal outside of that for like performance metrics. These could be things like database transactions are higher or even lower than expected. It could be perfectly normal on a Monday morning to come in and your database be doing 80,000 transactions a minute. And it could be perfectly normal for your database on a Saturday morning to be doing 2,000 transactions per minute. Machine's learning smart enough that when you come in on a Monday morning and your database is doing 2,000 transactions a minute, and it normally expects 100,000, it's going to tell you it's an abnormal amount. And better yet, when you use Management Cloud, it can actually point to why it's abnormal. The same thing goes for the reverse. It could be a Saturday morning. You could have, let's say, something like your network I/O is higher or lower than expected on an application server, and it sends you an alert, and it can tell you that your network activity on this application server is abnormally high or abnormally low, and that's causing, maybe if it's high, it's an abnormal load on the database. And using the suite of technology, it might tell you that somebody's now gotten into an application server and mining all your data straight out of your application on a Saturday morning and getting all the data that your application has. You have a data leak issue. This is very common. It's happened with companies like Equifax. It's happened with a lot of companies. It's happened with people in the cloud. It's a pretty common problem. And this is a technology that can detect that type of behavior. But it's not just about performance on the behavior and the machine learning. It also is smart that it learns what's your environment like, and it can do really cool things like align an error that the application server is seeing and align that with an error that the database is seeing and automatically tell you that they're related. So it really helps accelerate how you do your troubleshooting. And this is a key thing. And this goes into challenges faced by modern admins. If you look today, most larger IT shops, everyone works in a silo. You have a team of DBAs, you have a team of network admins, you have a team of application admins. The challenge there is when everyone works in a silo, it presents problems because you're not able to see the whole picture when you troubleshoot something. And often each team has a different tool, different technology they use to monitor their silo. But when you have an event, it's very common, especially with new applications where we're getting to microservices and agile development and DevOps, where these teams are having now work together. And there's a lot more dependencies between these technology pillars, these silos of technology, that you have problems with visibility across these, because you might have a developer that really needs to see database performance. And in the traditional model, they don't have that visibility. You might need a DBA to see what end user experience is like. And in a traditional model, that doesn't work very well. And then you have log files. And log files are a blessing and a curse. Log files, applications generate a lot of log files. Different locations, different formats. Often you have different privileges needed to see the log files. It's not uncommon where the DBA can see the DBA logs, the OS person can see the OS logs, but you have an application support person that can't see any of them. And they need that access in order to really troubleshoot a problem. And this gets into a capability Management Cloud is when it's pulling data in and actually looks at all the logs as well, and it gives you a better interface and kind of solves the log problem where everyone can see the logs they need to see to troubleshoot their issue. And it really addresses challenges of managing this. And speaking of logs, I just had a question: is log data secured in the cloud? Everything in Management Cloud is encrypted. Everything that's transferred to management cloud is encrypted, data in motion, and it's all encrypted and data at rest. So from a security aspect, you're secure there. A lot of it sits on top of Oracle certifications they already have. So for things like SOX compliance, the cloud already has a lot of those type of certifications. Management cloud sits on top of that, so they're included in those certifications in the environment. When I talk about management cloud, I really talk about big data, and I talk about how everything is integrated and working together. And one thing that's really exciting about it is it's taking data from a lot of different sources, a lot of different pillars, and putting it in one big unified platform, one platform that stores all the data. And this has some really interesting use cases for clients as well as operational efficiencies. It can start off with taking end user experience, taking what people click on their browser as they interact with the application, and seeing what a person does and seeing how long a system reacts to a button click. How long does it take for a page to load? How long does it take for menu options to be presented? And it pulls data in also from the application tier, the application itself. So if you're running a commercial application like SAP or eBusiness Suite, or you've written a custom application, it can pull metrics in from the application itself, whether it's log data or application metrics data, into the system, into this unified platform, into this one area of management cloud that stores all the data, regardless of the service or how it gets into it. It pulls in the middle tier. And this middle tier data is like your application servers, your WebLogic servers, your .NET servers, your Tomcat servers, your WebSphere servers, your Node.js servers. This pulls in all that middle tier of data, how those servers are performing, what are their workloads like. You have an ability to drill down, I'll show you here in a couple minutes, really detailed of what's going on at that tier. And then it pulls in the data from the data tier. And it's important that it's not just Oracle data. It does Microsoft, it does NoSQL, it does Postgres, it does MySQL, it does the NoSQL variants like Cassandra. It's pulling in all sorts of different data types and how those systems are performing, what's happening internally there. It then pulls in at the virtualization tier. So if you're running on VMware, it pulls in the VMware metrics. If you're running in the cloud, if your cloud provider allows the access, it can pull in cloud metrics. So we have clients that have run in Amazon's cloud, and it's pulling in some metrics there. Clients running Oracle Cloud, it pulls in a lot more metrics there because Oracle Cloud gives access to more logs and events of what's happening internally to their users. But it's also your on-premise system. So if you're running VMware, it pulls in all the data from your VMware environment. And it's always looking at that in combination with all the other data it gets. And it doesn't stop there. It starts pulling in the infrastructure data as well. So it looks at your switches and your firewalls and your load balancers and your storage arrays. And all that is brought into the system. And all that's put in this unified platform where it's looking at all this data and analyzing the data. And it can even pull in data from any data source you want. And I'll talk a little bit about that. An example I did at Open World is I pulled in data from the stock market just to show how flexible the system it is. But it's not just about putting the data in one repository. It's how it manages with it. And the first thing that it can do is it can take an application problem and it can identify that you have a problem with your application using machine learning. And it can tell you very specifically that you have a problem at the database tier or the application tier, or maybe it's a switch in your data center that's causing the problem. And it's not that even that it looks at a single tier, it correlates it across the entire stack. So you can see where an example I'll talk about where a user is having a problem with a transaction, and you can see the user's having a problem with the transaction. The application server is seeing a problem with the database. The database is having no problems, but in between the two, you can see there's a switch, and that's what's really causing the end user experience, and it automatically can correlate those type of events across the entire technology stack, regardless, again, if on-prem or a cloud environment. It also is a lot more efficient because there's a lot of other technologies that can kind of do this. But what you end up with is best of breed, multiple agents, where you might have one agent that looks at your logs, you have another agent that looks at your database, you have another agent that will look at your networking, you have another agent that will look at your security, You have another agent looks at your capacity planning. You might have another agent looks at your OS performance, and you might have another agent for your application. And all these agents start adding up. And pretty much every agent provider, every company that makes an agent, tells you the truth. Oh, their agent only takes up 1, 2, 3% points on the server. And that's generally true. The problem is when you start really want to monitor everything, you put 5, 6, even 8 agents on a single server. And if you think about that, each of those agents takes a couple percentage points. But when you get 5, 6 or more agents on a server, it's not uncommon to see 20% of the server's consumption of its resources being consumed by all these agents. One really good thing with Management Cloud is there's a single agent that goes on the server. That's it. So if you're using Management Cloud for different functionality, it's that single agent that goes on the server. And that's really critical because when you're paying for consumption in the cloud, if you're using a cloud provider and you're paying by the CPU hour, it's really important to have your system run as efficiently as possible. And if you're consuming 10, 15, 20, 25% of that system just for monitoring, that's money you're paying. 10, 15, 20, 25% of your budget for that infrastructure is overhead for monitoring. When you can go to a single cloud agent and now it's 1%, 2%, and that's it, that's a huge savings just there in efficiency. And it's not just the CPU consume or the memory you consume, it's also the network and the storage you consume. All the agents transfer data over the network. They all transfer log data. Some of them looks at all the logs. Some of them look at logs unique to what they're monitoring. Often you get log data, the same log data being sent 2, 3 times, becomes very inefficient. And that's a plus with Management Cloud is just from efficiency. The last thing we won't talk a lot about today, but it is there, is security. Management Cloud ability to can secure your environment from the access control and monitoring how users interact at a user level down into monitoring compliance and monitoring functionality at an application level and everything in between, and using machine learning to identify that. That in itself will be another webinar that we'll do here at Mythics, but the same technology manages that whole component on it. A little bit about Oracle's vision, because Management Cloud's nothing new. It started off as a next generation of Oracle Enterprise Manager. In fact, it's the same development team. And one of the things talking with members of that team that they had is they really needed a tool that was more cloud focused and worked better with the cloud. Enterprise Manager is a great technology and it's still there and it's not going away, but it had some challenges working with clouds. So when Oracle came out with Management Cloud, its first mandate, it had to work with the cloud. So they made a tool that worked with Oracle Cloud. That shouldn't surprise everyone. But the guys at Oracle were a little smarter than that. They weren't looking at just could this run on Oracle's cloud? Could this run on any cloud? So when they launched this technology, which is now a 3-year-old technology, yes, it worked with Oracle Cloud, but it also worked right out of the gate with Azure, and it worked with Amazon Web Services. And it also works with all your on-premise. And one thing to think about is this is a technology that works across all the cloud providers. It can even work with Google Cloud or some cloud that I don't even know the name of. It's just how the technology is built. It's incredibly flexible. You can have one monitoring tool that can watch a business transaction that could start with on-prem, go to one cloud provider, move to yet another cloud provider for part of the transaction. Because the reality is businesses and agencies are using multiple cloud providers, and maybe go back to an on-premise solution. And Management Cloud can give you a single pane of glass for that entire life cycle as the application workflow bounces between different locations, whether geographical locations or cloud locations or different on-premise locations. And that's a real uniqueness to this, is how easy it is to deploy. And I mean, you can deploy it anywhere. We've run workloads in Amazon, Oracle, in our lab at Mythics at the TIC. I've run systems in my basement. I've even run stuff on my mobile device where I'm monitoring applications on mobile devices. So it gives the ability to monitor pretty much anything in your environment. It is a cloud offering as well, which has some advantages because it's a consumption-based model to consume it. When you consume it, you start off generally with the first thing you'll consume is log analytics. And there's a lot of log tools out there. But something really unique with Management Cloud is all this machine learning. It uses machine learning to look at all the log data and to analyze log data and to correlate events in log data. And that's showing the basis of where you start. And you simply pay by gig of amount of data stored in the cloud. The next component you start working with are two services called infrastructure monitoring and application performance monitoring. And those are sold as what are called standard edition or the standard suite. Infrastructure monitoring will go into a lot more detail. That's your basic monitoring tool. How much memory, how much CPU, what are my workloads? It's all little graphs you're used to seeing. Application performance monitoring might be a little unique to you because with application performance monitoring, also commonly called APM, you monitor not only the application infrastructure, but you also monitor the end users and how they interact with the system. And because all this goes in this one big data repository, all these services work together. So application monitoring is going to instantly integrate with your log analytics, and that'll integrate with infrastructure monitoring. And you can start off looking at logs, and before you know it, you're an APM. Before you know it, you're an IM as you troubleshoot a problem. Generally, then you grow into the next upgrade, which is Enterprise Edition, which adds on IT analytics and orchestration. IT analytics is what I often call the C-level view of the environment. It's really around resource consumption and predicting resource consumption, showing where you have bottlenecks from things like lack of I/O, lack of storage. It can predict, will this server need CPU in 6 months? Will this application need storage in 2 months? It also helps look at your enterprise as a whole, and I see this really common with clients that use services like Amazon and Azure, where they just buy a lot of cloud and they kind of size their systems, and they end up with a lot of systems out there that are over allocated. They were told they needed 8 vCPUs, so they stand up 8 vCPUs, but the box never goes more than 25% utilized. And one cool thing with IT analytics is it can look at your cloud consumption and your on-prem for that matter, and it can tell you these systems are overutilized, these systems are underutilized. That might show you systems within a cloud environment. You might scale them bigger or smaller, or you might look at some consolidation. So it's really important for that type of efficiency and planning on IT analytics. Orchestration is the other one that comes in Enterprise Edition. It's what I call the secret service, because with orchestration, it allows you to have actions occur based off of an event being detected in the system. And it works with all the other systems in Management Cloud. A demo I did at Open World with orchestration is I took a machine running in a cloud and I put a workload on it. And once the workload hit a certain amount of abnormal consumption of CPU, orchestration detected that and automatically added CPU to the VM, hot scaling it. So the VPM got more cores, it got bigger as the workload got bigger. The bill went up as the workload got bigger. And as the workload eventually went up to like 4 times the standard workload, and the machine went up 4 times the capacity. But the utilization still bounced around between 40 and 60%. And the bill went up. As the workload went down, users stop running their reports, the system starts, having more resources unused. Orchestration detects that in combination of infrastructure monitoring and dynamically hot scales the system smaller. So it started pulling CPU away from the VM. And what that meant is while the workload went down, my utilization still bounced, 40 and 60%, but the box might have gone from 16 cores down to 12 cores, down to 8 cores, to an idle state of 2 cores, which meant the bill went down at the same time. And this ability, that's just one example of orchestration being used to react to something in the environment. And it can also act on other actions. It could see something on log data and fix something there. Or it could see something where application performance monitoring says the 3 app servers are overwhelmed. Orchestration could automatically stand up a 4th app server. So it gives you a lot of flexibility to react to things in the environment. You could even see something in a database, like an FRA becoming full, and orchestration automatically grow the FRA or clean out a file system or whatever you want it to do. It really gives you that autonomous capability where you need it. You could be autonomous in your on-prem, You could do autonomous in a cloud like Azure or Oracle or Amazon with applications you build in-house. The next service is configuration and compliance, and that one stands kind of on its own, and it's really for monitoring your systems for compliance for standards. So if you have something like a PCI standard for credit card processing, or you have your own internal operational standards, or you have standards you've developed for your HIPAA compliance, this can track all those standards and tell you the day that machine is no longer compliant, it's no longer compliant. The cool thing is, since it works with everything else in the environment, it also ties into orchestration. So you could have a system that's not compliant, and then orchestration can detect that through an event and automatically make the machine compliant. And so you can automate that compliance and that reporting of the environment. The next two components I'll put together is security monitoring and analytics and CASB. CASB is an API in the cloud. These both work for monitoring really end users and how they interact with the systems. CASB is really focused around your SaaS offerings. Are you using, Office 365 or G Suite or Salesforce or, Docker, a source management system or Salesforce or whatever? But it can monitor how users are interacting with these SaaS applications. When are they logging in? Where are they logging in? Really monitors that user behavior. When it sees abnormal behavior, it can then act on it. So it'll build a profile and it knows this user is logging into Office 365 and they always log in from Virginia Beach. And it's pretty much Monday through Friday and the occasional Saturday. And now it detects at 2 a.m. in the morning, they're logging in from China. CASB can detect that. Maybe that user got compromised, automatically lock the account. And that's a use case of CASB in the environment. It can do a lot more. It can monitor also how users interact in the internet with what's called proxy mode. So you can see data exfiltration, data that's your private data being uploaded to the internet. It can detect things like that in a more advanced configuration. And that will cover in more detail in our security webinar. The last component is security monitoring analytics. And it does what CASB does, really focused on on-prem systems. Systems that are on-prem that you can control, or cloud systems where you really control the OS. You have root, you have shell access to the system. And security monitoring analytics can pull data in from your firewall, can pull data in from the database, and it can see something like a DBA logs into the database and grants privileges on a table. And that DBA shouldn't be granting privileges on a table, and SMAX can detect that. It can detect that somebody gets into your VPN and then goes and tries to attack an application server and automatically sees that behavior. And then through orchestration, it can lock the account. It can do other actions. CASB and SMAX really work together. So often you'll see where somebody gets a piece of malware through an email, or they get phished on an email. You get the email that says your Office 365 account's going to be disabled unless you click here and log in. Surprised how many people click on that button. And then the bad guys capture your password, and CASB can detect some of that activity, and then SMAX can start detecting, and now they've come in on the VPN and they're attacking it, and SMAX can detect that activity, and together they work to lock the system down. The cool thing here is all these functionality works, and you basically pay for the component you're using, but it works with a lot of technologies that are not what you would expect coming out of Oracle. So out of the gate, it works with Microsoft, it works with Oracle, it works with Cisco, it works with Fujitsu, it works with F5, it works with NetApp, it works with EMC, it works with emerging technologies like Ruby and Hadoop in that space, or you can work with like Node.js, or you can work with Python stuff, or you can work with a dozen other different technologies. Out of the gate is not an Oracle-centric technology. Some of the use cases we'll cover and what clients have had, you'll see in examples of non-Oracle technology that out of the box it covers. In fact, the largest customer we've worked with this technology is mostly a Windows shop. And it worked great. It worked better than the Windows tools we're working in their environment. So it's a really unique offering. And don't think of this as a technology that's only an Oracle stack. It works much larger footprint. Of course, with that, everyone always asks, what happened to Enterprise Manager? Well, this works and complements Enterprise Manager. It doesn't replace Enterprise Manager. It complements it. Enterprise Manager has been around for a while. 13.3 was just released this year. And Enterprise Manager really excels at a deep dive into the Oracle technology stack. As a DBA, if I want to get into the internals of an execution plan, I use Enterprise Manager for that. But it doesn't do a really good job of event correlation. It doesn't do a good job of user experience. It doesn't do a good job of log analytics. And these are things that Management Cloud does a really good job of, because Management Cloud can work with the user scene. It can work to analyze the logs and correlate logs between the application and the database and the infrastructure and the operating system and the storage array, and merge all those together, understand what's going on in the environment. It also is a really good platform for cloud and non-cloud. So if you have components, in Amazon, it can monitor Amazon's as well as it can monitor applications running in other locations. Enterprise Manager doesn't do that as well, but the two really complement each other to the extent that Management Cloud pulls data out of Enterprise Manager when you're doing some of the IT analytics workload. So they actually work together, and they're built to work together in many use cases. Log analytics, like I mentioned before, is like the first entry point here. And log analytics is really about dealing with the log problem. We're getting more and more logs every day. Log volume is increasing, and every log tends to have a different format, has a different location, different privileges to see it. Log analytics gives you a single pane of glass to look at all that log data, regardless if it's data coming from switches, firewalls, your cloud provider, your database, your application server. And it's not just giving you a portal to look at all that log data. There's other companies that do that. It actually uses machine learning to digest the logs, to learn what's happening in the logs, to apply that to how your business, how your agency operates, and then using that to predict outages or to help you prevent outages. And when I say digesting logs, I do mean digesting logs. Some examples, the first line here, you can see where the customer number is highlighted. And it knows if there's a customer number, there's going to be an order number. And it knows it's part of an ordering process. And it will automatically relate customer number and Oracle number together based off that log line. And that could be really important, because if you're in the system looking at, I want to see all the orders from customer X, when you're doing that type of search, it can automatically expand it to see that customer number and all the order numbers. But you might have a log entry that just has the order number, not the customer number. It can still make that association and combine the data. It looks at it from an error logs, the next line. It sees closed connection. It knows that's an error message. And because it already knows that type of server, this happens to be a WebLogic server, it knows it's an error message, relates it to WebLogic. It's a WebLogic object type, and it tells you that you have a problem. So you don't have to go through and tell the log, if I see these type of messages, I have a problem. It knows it's a problem because it sees closed connection. It knows that's a type of an error message. Another thing it does really, really well is deal with timestamps. If you notice in the samples here, I think every sample has a different time format. And that's a challenge when I'm looking at logs, because if I'm looking at logs in an application, I'm looking at 10, 15, 30, 40 logs, and everyone has a different timestamp, and it's just difficult to correlate and put everything together. It actually takes that timestamp, breaks it apart, and digests that timestamp, puts it into the system in a unified internal timestamp, and not only does it get all the timestamps set right internally, it also can deal with time drift. And drift is a real big challenge, especially when you're dealing with systems in multiple data centers or multiple locations. You might have a system running in your on-premise data center in Ohio and have another system in an on-premise data center in Denver, and a third system running in a public cloud provider. They might all be slightly off on time. Every system in the data center is on the same time, but each of the locations might be slightly off. One of the things this does a really good job of is doing that alignment, understanding the system's 5 minutes off, this is 2 minutes off, this is a different format of the log file, and presenting them all at the exact same time. And this has been used that, okay, a customer had a problem in their Newark data center. At the same time, another piece of the application ran in another data center on the other side of the country. And the system was able to, even though the time zones were different, time drift was a little bit different, the timestamps were completely different format, was able to automatically correlate those events. That said, this application problem started because of this event on the other side of the country, impacted the application. The last thing is when it digests, it's not just looking at error messages, even names of hosts. So the last example is it's seeing the host name and it knows that format and knows it's a host name. So later on, if I'm trying to show me everything on a host name, it automatically has digested that format, knows it's a host name format, and allows you to search that way. One example of how this might look to rapidly identify an issue is this came from a demo where we see we have an issue in the database. And the database had an issue with I/O. At the same time, it saw, yes, the database had an issue out of the trace file, but it also saw the Linux system logs that it had an issue accessing storage. It automatically related all these storage issues at the OS with the database issue and said these issues are related. As a DBA, you know, yes, I had an issue. I had an issue because my operating system had an issue getting the storage. Instead of having to figure out who's at fault, you can immediately get the right person on for the OS and the right person on for the storage array and have that conversation of how do we fix this and how does it not happen again. And it's not just Linux machines. Here's another example from a client, and some of the data has been hidden. It's real client data, where they had an issue where the database running on a Windows server wasn't able to connect anymore. The system automatically took all these database errors of not being able to connect and it immediately correlated it to a problem where the Windows server itself couldn't get to the domain controller, which in a Windows environment is also the DNS server, and it automatically correlated that its inability to get to the domain controller is why it had problems with the database running on the Windows machine. So it's not just a Linux thing. This can correlate events on other platforms as well. And that's a real power of log analytics behind it. The next common piece is infrastructure monitoring. And the first thing I'll say with infrastructure monitoring is the more you monitor of your ecosystem, the more value you get out of this technology. Because it can monitor the CPU, your load balancers, the database, the app service, storage. It can also monitor your underlying technology, like your switches and your firewalls and your storage arrays, even the air conditioner in your computer room if you want it to. The more it can monitor, the more data points it can get, the more it can see of the whole environment, the more it can automatically correlate events and tell you what's the root cause of a problem. Another neat thing it does, and here's an example, is not only am I getting the normally I call squiggly line reports. Here we have an example of a CPU report. We can see our CPU utilization going up and down, which is you normally expect, and that's normal in an environment. But here we also see an area where it had abnormal CPU, and that's this area in orange. That's where it detected it was abnormal CPU consumption in that time period. And you usually don't get that in a tool, but a lot of tools give you the little squiggly line. This is unique that I can then click on this, drill down, and for that time window, see the processes that were running on a server. So in this case, I drilled down into a server and I can see the top service was a WebSphere application server. That's what was consuming most of the CPU for that time window that I was looking at. And I could also see I had that same time window, I had some network abnormalities of I/O, but I could see most of my CPU was that WebLogic, that WebSphere server. But I could go to another point in time when I actually had the abnormal event and look at that time window and look here and hey, where's my top CPU? My top CPU is being consumed by endpoint security software. And that's abnormal. Your endpoint security software shouldn't be your top consumption of CPU on a box. In this case, it was. It was the top consumption during the 1 hour time window that we were looking at. And this is something unique, is that when you look at the system and you look at the performance, not only do you see how much CPU is consumed, the tool has the ability to drill down and you can actually see the process command and the CPU and memory consumption of that process for that time window. And this is really helpful when you're troubleshooting performance issues, because you know it worked well today, but at 2 o'clock this morning it didn't. This gives you a view at 2 o'clock, not only what the consumption was in resources, but also even what the processes were and what they were consuming. And that's a really key thing that makes us different than a lot of the normal infrastructure monitoring tools that just give you the squiggly line of what the consumption was. And again, I can't stress this enough. This is not just Oracle. It works with Windows, Linux, Solaris, WebLogic, WebSphere, NoSQL, both database versions from Oracle, Enterprise and Standard, monitors ASM, Oracle's Apache, but it gets into Microsoft, does Microsoft database really well, monitoring metrics and MongoDB and CassandraDB and Apache web servers. It also has a new technology like Docker. So it can monitor your Docker deployments. It can monitor that infrastructure, your load balancers like your traffic directory, your F5. It goes on and more and more and more. And one of the really cool things is you can monitor about anything with it using a technology called Collectd. If you're a Linux admin, you're pretty familiar with Collectd. And you can take that Collectd data and also have that go straight into Management Cloud to monitor anything else. And that makes this really a powerful tool in monitoring the environment and understanding what's running where and what's impacting your application. And when you get back to that, that's important of what's running the application, because what do users care about? How often has a user as an admin called you up and said, well, do I have an index on this table? As a user, have you ever called up the WebLogic admin to go, what's my garbage collection like on my app? Users don't care about these technical things. What they care about is the application and how that's performing. And that's a key differentiator in Management Cloud that takes all the normal monitoring stuff we have in IT, but it gives us a huge ability to troubleshoot and to drill down into the application. And it really changes how we troubleshoot because of the machine learning. Old school troubleshooting, you start a crisis call because you have a problem. Everyone logs in from every technology pillar and you start looking at your underlying systems. You start looking at the stack from the bottom up looking for problems. Unfortunately, that means as technical people, we go down rabbit holes. We see an error. We don't know if that error is impacting the app, but since we started in our technology pillar, we start at the bottom, we work our way up, we end up going down rabbit holes. And sometimes that takes us an extra 2 or 3 hours before we realize it's not impacting the application. It's not the cause of it. Also, a problem is you have multiple groups using multiple tools. You have debate about, is this a problem or not a problem? And that takes a lot of time to resolve the problem. Eventually, though, you get to where the problem is, you resolve it, and users are relatively happy because the problem got resolved. But with Management Cloud, especially with APM, it's the easy button. Because instead of starting at all the underlying pinnings of what makes the application run, you start with where the user sees the problem. And you can see what the user saw. You can see the errors the user saw, and you can drill down from where they started from to where the problem started or what caused the problem. So you start at the top of the stack where the user had the problem. Machine learning helps you get down right to the root cause of the problem. You can see where the problem was. You can see the pain point, and you can resolve the problem faster. And it really changes how you do troubleshooting in this modern environment, regardless of where your application is running. APM looks at a lot of different metrics inside the application. It looks at AJAX, server requests, log files. That's why log analytics is your start. What's cool versus other technologies that do this is APM uses the machine learning to automatically discover the application topology. So where a lot of technologies, you have to tell it, this application is using these 4 databases and these 3 app servers. And if you add an app server, it doesn't know. So you have a problem, somebody forgot to add it to the monitoring tool, now it doesn't look there for the problem. With APM, it automatically learns the environment. So once you tell the entry point to the app, it'll automatically discover the databases, the app servers, the components that reach and surround the application. And when that changes, and we know in IT we have change, it automatically rediscovers what's changed and adds that to its logic. It's integrated with everything else in OMC, so it automatically pulls log data and application data is all integrated with APM, so it's pulling from other data sources. But most importantly, it gives you true visibility across all the technology silos, from the application owner down to the low-level admins that are monitoring the hypervisor, or the cloud, or the database, or whatever, and everything in between can see what's going on with an application. And you get a pretty comprehensive view. And the view looks like this, and this is an example I took from a system. And right now I have pages by geography, and that is showing the geography of the site. So we can see here world geography of hits to this application. The page views, I actually, is a demo, plug this into my blog, tells them the data center, it's just pulling web traffic from the blog. Again, this works with off-the-shelf technology. I plugged it into WordPress, had it up and running in 5 minutes, and was pulling data into it for blog traffic. And you can see the total views. You can also see as an app admin, I can see all the services what services are being called. In this case, the box size is looking at the total number of calls. So I can see this service right here had the most calls involved. And then it's also looking at the color for the response time. So I can see the worst response time is this box here between the different web services. I can also see for the entire environment how many pages are being monitored, the number of service requests that are unique service requests, and the number of app servers and their metrics. Here I happen to have them sorted by peak usage for application server. Server requests is sorted for response time, and pages are average load page time. But all this data you can drill down into. So an example, I was looking at the metrics and saw there's a lot of traffic from Europe. And so I drilled down into Europe. And now I can see a map of Europe, and I can see total page views. There's a lot of traffic coming from Spain. There's a lot of traffic coming from Germany. Germany's fairly normal. I know UK and France is pretty normal. Spain, that's a hot spot. That's not normal. So let's drill down into Spain, and I can see something coming from a specific region in Spain generating most of the traffic. And I did a little research because I was really curious, why am I getting all this traffic from Spain? There happened to be an IT conference in Spain, and apparently when there's an IT conference, my blog got more traffic. But this is the type of drill down you can get. And you can do the same type of drill down in the US. Sorry, the US view, go down into the state, and then bit by bit, they're adding deeper drill downs by state to get into metro areas as well. But it's not just the geographical view. I can look at all the sessions to an app. So this is another session from a client. Everything's been blurred out with it. You can see all the sessions, and this is sorted by what's called session health or application index. And this is a score that combines errors and performance. And here I've sorted by the worst sessions. So I can see a session came in. I can see the location, the IP address. I can see the type of device. It happens to be a Windows device. And I can see they were in for one page, had 2 JavaScript errors, and had a pretty low score. I can drill down to like another session. This guy was in for 7 minutes, 16 pages, 98 AJAX errors, 2 JavaScript errors. Well, let's see what caused more of that. So I can drill down to that user session and drill down. And I can see when that session came in, I can see their browser. I can see their screen and window size, which is very important data for the app developers. And I can see the page clicks, the page views. I get a timeline, and the timeline tells me when I had interaction with a page, a web service call, an AJAX call, a click on the page. But I can drill down more and actually see what they saw. So here's an example where I can see one particular URL took. I can see it took almost a full second to load. I know from the point it started to load to it end to load when it's interactive, and that's an important metric. One thing I saw is the user saw a whole bunch of 404 errors on this particular page. A lot of 404 errors on here, and this was causing the page not to load correctly. The result was this particular client, they had a third-party application. The third-party application developer did a part of their service, did an upgrade to the application. They did a typo. That happens, unfortunately, and it caused all the graphics to load from the wrong location. So anytime a user went in, this immediately saw the graphics weren't loading right. And you can drill down more, and you can see where people clicked on the page and what they clicked on the page and the response for there. So you can drill down at that detail level. But you can also look at the application server back up at a higher level. So here I can look at my 3 application servers, and as a as a Java app server, I'm always looking at heap and garbage and CPU, and I can look at those metrics as a high-level health. I can drill down into a particular app server, and I can see over a time window, what were my metrics like for a heap? What was my garbage collection like? What was my average response time? What was my load? So I get a health of the application server. I can drill down into all the server requests that are running on that app server. So here I looked at app server, and I see a whole bunch of service requests. And for each of those service requests, I can see metrics. Like here's a service request. It averaged 3.64 seconds, which is not great, but there's not bad either. Here's a service averaging 1.38 seconds. So I can see that response time for that particular service over the time window that I'm looking at. And I can see for the service where it spent its time. So like here's a service that took 3.63 seconds in the app server, spent 11 milliseconds in the database. And this happened to be with a client that was having some performance issues, and they were initially told it was the database. Well, we pulled up, looked at it, and said, no, this app is spending all the time in the Java. It's not spending in the database, but let's drill down and see what's going on. So we're able to drill down into that service request and get an architectural diagram of that application service. And here we can see where the calls are internal to the Java. We can also see all the external database calls it made to the database. And we can see that it's spending a lot of time in Java, a lot of recursive calls, not a lot of time in database. So we can kind of get of this one service, what it looks like architecturally, drill down at a high level, see an overview where resources are being consumed. We can even drill down into something that's going to look a lot like an execution plan for DBAs. And you can see as it steps through this particular flow of the application, it hit this class, it had this call, it hit the database. Here's a database transaction. It called one time. It had 1 millisecond response time, which is great access from a database. Here's a call it called 29 times. It averaged 0 milliseconds. So it was sub-millisecond average response time from the database. No problem with the database at all, and you can actually get an idea what the SQL is in this example. But you can see where it spent a lot of time in the application server. So you can drill down there for the service request. You can even say, well, it still could be database, so you can click on the database tab, and you can see every database transaction that service does as a whole, and you get metrics. So we had 29 calls. Our slowest call was 1 millisecond. We averaged 0.24 milliseconds. Our fastest was basically 0 millisecond, sub-millisecond. So we're getting really, really good database response time, and you can get that granularity. You can show is it the database, is it not the database? Where's the pain point with APM? So that's kind of a high level APM. Wanted a couple of real world examples where this has helped clients. First one, this is with a client, primarily a Windows shop, and I call this "Are you logging?" And this was a really surprise to the client. We deployed log analytics to all their Windows servers. This is a very large Windows environment, and we set it up that when a Windows server was added, just when the Cloud Agent was installed on the Windows server, it automatically turned on log analytics. Almost immediately after deploying this, we had errors on one server. And we're like, why are we getting errors on just this on one of the servers? So we looked at it immediately afterwards, saw that all these security events for that server haven't been logging. And security events, the privileges were changed where security events on a pretty business critical server for this client were not logging. The interesting thing is not only were they not logging, but when the client started looking at it, it hadn't been logging for 4 years. Something their normal monitoring tools that they had been using had not detected for 4 years at one of their critical servers, had not been logging security events for that long. And that's an example, real world example. We talked about it with Open World on it, but that was a long time, 4 years and no security logs from a server. Another example, this was a client with PeopleSoft, same client. And the client thought, yeah, their PeopleSoft environment was clean and healthy. They're having some problems. APM detected that when the users were in the system, when a user logged out, that they immediately got an error. And actually, the error would be seen on the browser. The browser would pop up on PeopleSoft and give an exception error. And the browser didn't like a Java exception error, and so they had to restart the browser. And this system actually detected that going on, and the cause was actually made because of admin made a change to the JavaScript for the PeopleSoft logout and had broken that logout component of PeopleSoft. And they broke it. They didn't know where it was broken. They didn't know how to fix it. As soon as we put APM on it, pretty much told what page and where the JavaScript was that was causing the problem. It took them a couple minutes to fix. That's another real world example. And it's not just as something broken, it's also around capacity. So here's a component using a couple of the tools with VMs where a client was having poor issues with VMs. They had poor database performance. They had some web logic failing randomly. They had looked at this with their server team. Their server team and their hardware vendor was outsourced to a hardware vendor. And the hardware vendor was also their outsourcing partner and also where they bought all their hardware from and software from. The vendor identified that, yeah, you're on VMware, you need more servers. It was going to be about $200,000 in expense to add on a couple new VMware servers because you just don't add on the hardware. You also have to add on the licenses for VMware as well as additional hardware. Well, infrastructure monitoring, we looked at it with that, said, hey, look, these boxes, they're only using 1/3 of the CPU. They're using 100% of the memory. Let's look at the model number of the servers. Adding VMware servers because you're out of memory doesn't make a lot of sense if you have plenty of CPU. We looked at it with the client and they said, hey, you're right. This tool is telling us that we have plenty of CPU and we're not going to exceed our CPU needs for quite some time, but we're out of memory. It ended up being cheaper for the client just to add memory to their existing VMware servers, and they saved about $160,000 for the cost of the memory versus having to buy all new servers. So this is an example where IT analytics, infrastructure monitoring can kind of show where when you need resources, it's not always what you're told. There might be more to the story and you can save some money there. The last one is a troubleshooting issue. And this one we used application performance, infrastructure monitoring, ITA. We used most of the technologies. User is having intermittent performance issues with an app. They knew this before the proof of concept. They knew they had problems. We put APM on there and APM was immediately detecting problems, and it's problems they knew because they knew the application server was saying the database was slow responding. And they knew that, and APM showed that. And that was, okay, the client was like, okay, this is already showing us what we know. And the database was running fine because they had all their teams looked at, their networking team, their database team, the app server team. Everyone had looked at and said all their environments were healthy with their tools. So no one could find a problem of why this intermittent performance problem would start, run for a couple of minutes, and then go away. There's a lot of heated contention between the database team and the application team because the DBAs couldn't find anything wrong with the database, and the application team showed that in the WebLogic system, they were getting slow response from the database server at times. But we also deployed APM across the whole environment, also deployed it on the Cisco switches and with infrastructure monitoring. And at the same time, the APM detected the user was having a performance problem, was the same time APM was detecting that the application server was getting slow database response, was the exact same time infrastructure monitoring was detecting that the switch ports were flapping, which is when a port goes up and down rapidly, was at the same time a switch port was flapping between two switches in their lab environment where we were doing this proof of concept. And it matched this all up into this one event saying all these events are related. What was happening is the Cisco had these two ports that were flapping, and ended up being they replaced the cables basically that connected the two switches, and the problems went away. But when these ports were flapping, it was causing network to perform poorly, and that's when the users had issues. And this is where example where I talk about with this technology with OMC, deploy it everywhere because you might think you have a database problem, and it could actually be, in this case, it was a problem with a switch. And it was just some hardware on a switch that had to be swapped out on the cabling of the switches. And this is an example of where that machine learning automatically identified the whole stack once we had the monitoring in place. So that's another real world example that we've talked about here. We did have a couple questions. We'll open up some more questions here. Did have a question on the system about monitoring mobile devices. Yes, this can monitor the applications on mobile devices. APM will monitor .NET or will monitor iOS and Android clients in the app. Have another question. Can it manage patching? Yes. One of the things Management Cloud can do is it can, from infrastructure monitoring, it can tell you what a version is. And then if you want, you could have an OMC job orchestration job that goes ahead and patches to meet a version. Compliance and configuration is really where that kicks in because you can write rules that say this particular RPM file or this Windows patch or this database patch has to be applied. And then you can write an orchestration rule that will apply the patch. So it can do that if you want. See if we have some other questions coming in here. I see a couple people typing. Question is, can it monitor AIX? Yes, this can work with AIX systems. It works with Windows, AIX, and Linux and Solaris. Infrastructure requirements, it's cloud-based, so the only thing you really have to deploy are the cloud agents on your systems. Depending on your network topology, most of my clients also use what's called a gateway system, and I highly recommend gateways, even when they're not required. The gateway system acts as kind of a consolidator. So all your clients in a location will talk to a gateway or gateway cluster, and then the gateways talk to the internet for Management Cloud. That takes up a little bit, a couple CPUs. It's not a large footprint. If you're running OEM and you want to get data out of OEM for IT analytics, you'd also put in what's called a collector, and that pulls in data from Enterprise Manager and pulls that into IT analytics. And again, it's a very small footprint. Most agents are running 1% or less. Occasionally, I'll see an agent bump up to 2 to 3%, but it's fairly low overhead. And since it's only one agent that needs to run on the server, you don't run into the issue where you have 5, 6, 7, 8 agents all consuming 3% at peak. So it ends up being a lot more efficient as far as requirements, lower overhead. If we have any other questions here, see someone typing. Can this be on-prem or as appliance? Well, this is in the cloud. So this is a hybrid approach. All the main processing is done in the cloud. On-prem is the small footprint of the cloud agents. There is no appliance that does this all on-prem, so you have to be able to use cloud solutions. But this does sit, everything is encrypted, and there's a lot of standards behind it from a security and compliance aspect. Okay, well, I'd like to thank everyone for attending, and if you have any questions, please feel free to follow up. You can go to mythics.com and contact us from there. If you have any specific questions, feel free to drop me a note. I'd be happy to answer your question and put you in touch with the right people that can help you out. Otherwise, thanks for your time, and hopefully everyone has a good day.